discuss an Ethereum improvement proposal, upcoming upgrades, and the basics of Ethereum blockchain. I'm Pooja Ranjan, and today we are going to discuss EIP-4444's bound historical data in execution clients with one of the co-authors of the proposal, Alex Stokes. EIP-44 is a standard track networking EIP proposed in November 2021 that is currently in the draft status. And to provide the overview of the proposal, let me welcome Alex, who is also a developer and researcher at Ethereum Foundation and is mostly engaged with Ethereum beacon chain development. Thank you for joining us, Alex.
Yeah, thanks for having me. So yeah, today we're going to talk about EIP-44s. Just like sort of a quick intro. Pooja, said some nice things, but yeah, I with the Ethereum Foundation, one of the co-authors on this proposal. I spent a lot of time more at the consensus layer, but finding myself spending a little bit more time lately at the execution layer, and as especially as we come to the merge that everyone is, I expect, so excited about. These things will become more and more relevant to talk about at the same time. So either way, I have some slides we can run through EIP-44s. If anyone on the call has any questions, please stop as we go. Yeah, should be fun. So yeah, EIP-44s. I'm Alex Stokes. If you want to follow me on Twitter or find me on GitHub or Telegram, my handle is @AlexStokes. You see it there at the bottom. And yeah, so the first question is what is 44s? What does it propose? So the key thing it wants to do is change the guarantee that we have today, that if you run an execution client on the network, it has all of the history of the entire chain for all time. This means I could go back to I don't know, the 10th block and say, what was, give me a transaction in that block. And that's great in terms of making the Ethereum node be responsible for that service, right? But as we'll see, it actually doesn't, it really doesn't scale. And that's what 44s is trying to drive at, is that and I'll say this later, but if you think about this, let's say, we're running the Ethereum protocol in 50 years, even 100 years, you won't care about a transaction that happened today. So why would your node want to keep track of it, right? So anyway, I'm getting a little ahead of myself. Specifically what 44 says is that we're going to drop this guarantee. What that means is that on the peer-to-peer networking layer, no longer can you get blocks, and that includes the headers of the blocks, transactions in the blocks, and also omers, which is just this historical sort of proof work function that's going on with the merge. But either way, they exist, are important for history. And then also receipts. So a receipt here is when you execute a transaction on Ethereum today, there's basically some side effects, and these side effects are recorded in this other data structure called a receipt. And they're important. They're important for clients. They're committed to in the block header. And yeah, if you're a DApp developer, you've seen logs. You've I'm sure run into logs either in Solidity or events in Solidity or logs with the protocol. These receipts are where the logs live. So they're very important in terms of using the protocol. And importantly, 44s does not touch the execution state. So this is a distinction that's actually quite important. There's if you think about the blockchain, there's a chain of blocks. And when we say history, we mean basically all of these really old historic blocks in the chain. Separately, you can execute, the transactions in these blocks, and they perform some mutation to this state that we'll look at a little bit more in a second. But basically, there's the Ethereum state, and that is kind of its own can of worms in terms of managing the state. And there are various ideas around state expiry. I'll just go to the next slide now. So yeah, just a quick aside here. There's this notion of state expiry, very different from history expiry, simply because with history expiry, as we'll see, there's probably some very simple things we can do to get a lot of the benefits. Whereas with state expiry, it's so much, there's just so much sort of subtlety and intricacy around handling the state that we're probably going to need a whole different approach. So 44 says, okay, we can do a lot of good just by managing history growth with respect to a full node. We'll leave the state alone, and that's someone else's concern. So if you're watching this and you're interested, I believe this is the latest thinking. Is this document Vitalik has written on state expiry paths, and there's a few different options there. Again, it's still an open sort of R&D sort of research design space. And yeah, I mean, there's a lot of interesting research for sure that's coming out of that, but yeah, it's a whole different thing. So 4-4 is concerned just with the history of the chain. And again, you know, like you could probably drill down and like there's like some like specific technical things you could like talk about, but really more like 4-4 is about changing the guarantees of the protocol. So it's almost more like a concern of the social layer, not so much like, okay, like, is there this like very crazy like cryptographic witness to like give us nice statelessness or something like this? Like there aren't these like really core deep technical challenges that we need to solve with 4-4s or like history expiry in general. It's really more, hey, if you're a dApp developer and you suddenly don't have your logs from like 2 years ago, is that okay? And what does that look like? So a lot of like writing this EIP was to like basically to start this conversation. And I'll summarize some of this later on in the talk, but I think that's kind of what we've gotten to is like right now we're still just gathering input from like all the different community members because like this is like a core guarantee the protocol does provide, and like it really does touch on like so many different actors in the ecosystem. So hopefully we can align them all one day and do something here. But in the meantime, we have the CIP. So to like motivate this, you know, we can ask like, what even is Ethereum? And like, this really is the question, because you're like, okay, what guarantees does the protocol provide? Well, what does the protocol do? And like, if we can agree on what the protocol does, then like, I think the guarantees should be obvious. But either way, here's one definition. And really it comes down to the state. Like Ethereum is the shared state that we all have. Like if you run the protocol, then you have the state. Along with that, you have a permissionless protocol. So some rules for running Turing complete computations on this state. So like, not only do we have this state, like this, like, you know, this like data or information that we all agree on, but moreover, there's rules for how to like change it. And like, that's where all this sort of the power and flexibility of the protocol comes from. So like I said here, yeah, it's very powerful. You can do things like program a currency. So that's where we get Ether. You can program like sub-currencies, and then you have all these ERC20 tokens. But you can do more complex things. You can have like the state of a decentralized exchange, right? Because you do have this like Turing complete richness, you have this expressivity to say things like, okay, this is now like a constant product or constant sum decentralized exchange, and you can build that on Ethereum. That's where we get things like Uniswap or Curve. And then again, if you're in the space, I'm sure if you're watching this video, you're aware of all this stuff: DeFi, NFTs, DAOs, metaverses, all this stuff, right? And your idea here, like, there's like so much that's possible with the protocol, and I think that's what like attracts everyone to the space, because it's like there's so much potential here. But anyway, this is not me talking about Ethereum. This is me talking very specifically about history expiry. So point is, there's a state, and we have this protocol to change the state. This definition will actually be really important, because really to answer this question, what are the guarantees, right? Like I said, we're going to have to answer this question. So anyway, we at least have a working definition for what Ethereum is. So then the question is like, okay, if we have this node, we have the software that implements the protocol, like what does that node do? This permissionless bit is actually quite important, because what it means is anyone can make transactions, anyone can make a block with those transactions. And so as a node, you have to verify that, you know, the next block in the chain is valid. So you're going to collect blocks from your peers. Currently, and again, there's like various research efforts to like change how the statement reads, but what happens today is you re-execute all the transactions, and that's how you know if they're valid. And then importantly, once your node has executed things and determines what the state is, that state's exposed to end users. And so that's where like when we do things like build Uniswap dApps, like we can say, oh, like here are all these liquidity pools, here are like these trades that happened, and we can actually like build applications with this stuff. So it's actually quite important that like, you know, people can actually interact with the state. And yeah, this takes various resources, right? So like this has a cost, and the cost in terms of running a node is like the computation, the disk footprint, the network bandwidth, all of these like technical resources that have to go into this in terms of operating the protocol. So if it has a cost, right, we can say, well, how expensive? And, you know, ultimately that's a relative question, but yeah, I mean, a lot of it is that, you know, everyone comes to the protocol, they try to interact with it, they try to do like a token swap, like I was just talking about, and they're like, oh, like the gas costs are so high, why is this? Well, this reflects the cost of operating a node, right? So if it were somehow radically cheaper to operate a node, then like with the same sort of security parameters that we operate the protocol today, you could like, you know, essentially the gas cost would be much less, and some unit you care about. To give a flavor for this, one element, right? Because I said there's like a couple of things, right? It's basically like you have all this like computer hardware you have to throw at, you know, throw at running a node. So to give you an example, some flavor for this, one you know dimension to this is the disk footprint, and so that's what I have here. You can, if you run a Geth node, you can run Geth db inspect, and it will basically go walk through your local database and tell you, okay, you know, you have these recent headers and they take up this much space, or block bodies and they take up this much space. So you can see this chart here, and this was from a Geth node that I synced just over the weekend, so it's super fresh, version 10.16 if anyone is interested. Point is, you see here at the bottom, you know, it takes half a terabyte, 500 gigabytes, right? So that's like a lot is the bottom line. And so like what 44 is trying to do is say, okay, and there's other dimensions as well, right? In terms of compute and also networking. But the point is that having to sit from Genesis and like sync the whole chain, it already takes, you know, 500 gigabytes of storage, you know, on disk. And the question is like, can we reduce that, right? And in a second, we'll see it's important to keep this as small as possible. So I did do this call here with the red box, and it's just to say, so there's some, you know, differentiation the Geth software makes between like recent values and like ancient values. I don't know exactly what this cutoff is, but approximately we can say this is about what 44s would basically say, okay, you could drop. And it would be the stuff in this ancient store. And so you look, it'd be like headers, block bodies, receipts. And if you total this up, this is like 300 gigabytes. So that's over half of like the disk footprint already. So like if we ship 44s as is written right now, then, you know, you could basically suddenly like run 2 execution clients, or like the, you know, you'd suddenly have so many more resources just immediately. And yeah, like I kind of was alluding to this, like, why do we care? Well, it's important both in the short run and in the long run. So in the short run, it's like, okay, yeah, like for me to do this, I need to have a big enough disk. And like, you can imagine, again, going to my prior point, like if we're running an Ethereum protocol 10, 20, 30, 50 years from now, like this is only going to get bigger the way that the protocol currently works, because the way it works is that as a full node, you're responsible for the entire chain history. So it's only going to get bigger and bigger, right? So like this just flat, you know, plainly does not scale. And then also, right, again, in the long run, you have the same issue where it's like, and this is what I was just saying, where it's like, yeah, 50 years from now, like you don't need, you know, okay, the issue is that if in 50 years from now, we don't change the guarantee we currently have, then you're going to need some like very, you know, high powered disk to even like have all this data, along with computation, along with networking, all this stuff. And that's the issue, is that like the more like sophisticated the hardware requirements are needed, the harder it is to run a node, which means fewer people will do it. And this is, again, in this bottom bullet point, what I was calling out is that basically with higher cost, you end up with more security, simply because fewer people are running nodes. And that's like where Ethereum gets its centralization, and that's where a lot of the potential and power comes from. And then also, by the way, this is the same reason we can't just like 10x the gas limit. People will like always ask for that. And it's just like, well, it's not that simple. Yeah, so 44 says, okay, it's already reasonably expensive to run a full node, right? And it's only going to get worse. That's actually really the important point. And so like this notion of just like having the chain monotonically increase forever doesn't scale, full stop. So 44 says, okay, if that's the case, what are we going to do about it? Well, one thing we can do is just say, yeah, cut the old history, make it someone else's problem, take it out of the core protocol. And so that's what the EIP says, is we're going to change the guarantees on the peer-to-peer layer, where basically now these headers, block bodies, receipts, these historic parts of the chain that like honestly are sitting on your disk, and for most users you actually don't need them, like you can just get rid of them, right? And so what that means is that if I'm a peer-to-peer node on the network and I'm syncing the chain, I would basically go to a peer, and I might need something, you know, let's say I asked for something from 2 years ago, if the cutoff period is 1 year, they wouldn't give it to me. And again, that's like changing the guarantee. But anyway, so the EIP says, yeah, we'll do this. We need some cutoff period. Right now it says a year. I think that's actually about a good value, but obviously, we could debate that, the specific value. But anyway, the point is that if you have this, then that implies that your node doesn't need to keep the chain history, for example, because it doesn't have to provide it to your peers. And so because of that, you can just delete it. And suddenly, like I said, this red box here could just be gone. So huge savings right out of the box. Importantly, if you don't have this information, it also means you can't give it to users. And that's like probably the bigger sticky point, I think, with the EIP so far, is that a lot of people rely, like I said, there's events in Solidity. These are implemented as logs within Ethereum and the protocol. And people use them. Like if there's a transfer into like a Gnosis multisig, like there's a log that's fired. And so the issue is like, okay, what if you need to like audit that multisig? Maybe you want to audit like funds flowing through it. And suddenly you like can't just look 13 months ago because 12 months have passed and that's the history cutoff. Like that is not great necessarily. So 4.4 does need to provide an answer for that, and we'll look at that in a second. But either way, in summary, we want to change this guarantee, and that means that you can basically save a lot of resources that you currently need to run a full node. So maybe I've convinced you by now, and like, what do you want to do? So we still have to answer some questions, and this is what I was alluding to, like, how can the history be validated? It's still very important that we be able to like say, okay, this was the Genesis block that we all agreed to. How do we get to today's block? If we do this, then the question is like, okay, we definitely still want the history. Someone needs to provide it. Who's going to do that? And then if they do it, how are they going to do it? These are all questions that are sort of tangential to the EIP and like we're actively looking into. So yeah, like I said, it's like very critical to Ethereum's values, because like even if we get rid of this guarantee at the core protocol layer, like in terms of like, for example, if we do say, okay, the peer-to-peer networking layer no longer serves as historic data, that's fine, but you still need to be able to say, okay, I need some way as a user of the protocol to validate. I don't want to necessarily have to rely on someone else. And so how are we going to do that? So the IP basically says we'll make this Shim client. So what this means here is, rather than have like a sort of full node like they look today, you could have something that's even a bit more stripped down, where it says, okay, I'm now basically this like offline data processing software that says, okay, I'm basically going to just like read Ethereum blocks, and then I know that from this block number to that block number, there's a certain format, a certain rule set, and then I'll be able to validate them. And the idea is like, rather than having execution clients today where they have all of this stuff in them, you could basically drop the old code, because that moves into this like separate client that is just available, in some open source fashion for anyone to use. And the client then can say, okay, for this range of blocks, I do this, I do that. And then you could basically say, okay, here's like a whole batch, basically here's the history file. It could be many terabytes. Like it actually, it could be the whole chain. And you could say, okay, here's a chain. Even if it takes you like a week, like just sit and do it. And then at the very end, tell me like what the state is. And then from there, I can hopefully get to a more recent state. And then from there, there's other techniques we can employ to figure out, okay, given this recent state, does this link up with what I think the head of the chain currently is? And yeah, I mean, that's basically what this says here. So there's an answer for how the history would be validated. And basically, yeah, it's just providing the software to do the re-executions. A more interesting question is like, who will provide the history? So the thing is, you only need a few actors, right? You just need a few like reliable, they could be very well established players in the ecosystem that are providing this history. There are, of course, like censorship risks to having just a few, but it's definitely the position of the EIP that, we think there'll be enough like trustworthy actors in this space that like can, provide the history. And when I say trustworthy, I don't mean that you need to like, because you can still independently verify. It's more just like, this is more an availability question. Yeah, we think that there will be people who provide this data. It'll be so important, at least in my opinion, I think it'll be so important that like someone will do it. And like importantly, I say it's like an archival use case. So it's like, even if you are a provider of this data, it's something where you're going to probably write the chain, every so often, there's some like very low frequency, just to extend your local history. And then, like we were saying earlier, most people aren't going to like need transactions from like 50 years ago or like 5 years ago, right? Like, so because of that, like there's going to be a very low volume of reads. So it's like, you can have like sort of an optimized sort of hardware setup and operational environment for this that should hopefully be low cost to operate. And yeah, it shouldn't be that terrible to provide the history. And I gave some examples here, like, here's some ideas about who concretely would provide this data. So there could just be altruistic actors in the space. So like, for example, the Ethereum Foundation could be like, okay, we're just going to host the history forever and like provide it at some endpoints that hopefully is, again, not too expensive to operate, and like we can just freely provide it to whoever wants it. We've had some inbound interest from the Filecoin team, actually, like people at Protocol Labs who want to kind of, I think, demo hosting the chain history on Filecoin. And basically as this is an incentivization layer to IPFS. So that could be really cool. Like, so we can have some cool collaborations there. The Internet Archive, sorry, I need some water, but I don't have any. The Internet Archive. So yeah, the Internet Archive basically just wants to archive the entire like web. We haven't spoken, at least I haven't spoken directly with them yet, but the idea is, they could say, yes, Ethereum is this important service. So we're going to, the same way we archive the web, we'll just also provide an archive of the chain. You could have other actors in this space that like maybe aren't as like altruistically motivated, but still like see it as like a value add for them, right? So like Etherscan or Infura, you could say, hey, you guys are running these like really profitable businesses. You could also provide this, again, hopefully inexpensive service as a benefit for the community. Just as like a way to gather goodwill. And like a cooler example, I think, is some sort of public goods DAO. So you can imagine, people actually use the chain to coordinate on preserving its history. So that could be pretty cool. And even if the DAO itself doesn't like I think the idea is more sort of almost like Lido or like Rocket Pool style, where like the DAO is like actually in some way like decentralized, in a decentralized way, like maintaining the chain history, almost I guess like Filecoin. But either way, even if you don't go like down that road, you could still just have a DAO maybe raise funding and like somehow provide that funding to these other orgs. Anyway, the point is, the position of the EIP is that there are probably many players who will do this, and we just need a few, and so we're good there. Then again, last question, how will we get the history? So this is almost a bit of an implementation detail. There's some ideas around like, even just making torrents and using BitTorrent to like distribute the chain history, traditional like FTP, like data mirrors. And then yeah, something like Filecoin, IPFS. So using Filecoin essentially as a service to basically host the chain history there. There's like a couple options. You'd honestly probably want to see them all used in parallel. So yeah, I don't think, at least as far as this EIP is concerned, I don't think this is really the contentious point, because there are plenty of ways to like retrieve archived data. Like that's a very common thing that happens outside the crypto space even. Some interesting pushback we've gotten so far is that essentially we would basically want this part to be in the protocol itself. So like you could imagine a separate like dev P2P protocol that implements history retrieval. And then nodes can opt into that, so not everyone runs it. But yeah, that's a bit of a open question right now. We can get to it later. On top of everything I've said, there's now a bonus round, which is the merge. And what happens with the merge is that we move to this proof of stake security model. Part of what that means is that we now have this notion of weak subjectivity, where basically what happens is that as someone who follows the chain, the proof of stake chain, unless I'm following the recent validator set, I actually wouldn't be able to tell the right chain. And that's because there could be enough churn. So basically what happens is I'm following the chain, I know the validator set, I go offline. What happens then is there's enough churn in that set that now I could basically have like conflicting views look completely plausible to me, because I come online sometime later, now I get these two views and I don't know, right? And within proof of stake, there's no way to actually resolve that. So in parallel, we were spinning up this notion of like weak subjectivity, a way to distribute weak subjectivity checkpoints, a way to resolve this issue of long range attacks. And it turns out that like you can actually use this to like as a sync paradigm, where basically all you do now is you have a recent trusted checkpoint, say like, you know, the recent state hash. From there, you can say, okay, now peers on my network, give me the data that aligns with this hash. And then maybe there's like some notion of like, okay, I'm at like a, you know, the block from this morning, and then I'm going to like backfill the history. There's history. I'm going to backfill the history to say a year. And I could stop there. For example, if you implemented, you know, 4.4s, then like we would just stop after a year, and that's that. So it pairs really well, and like it's kind of happening anyway, is the point I'm trying to make. There's also a bonus round, even a little more forward looking with some of the research, is like this introduction of statelessness, where the idea is that now, and again, this won't be a statelessness talk, but at a high level, the idea is blocks now are going to carry their own history in a sense, where like if I need, basically if I have a stateless block, it contains with it the state or the history that it needs, and then also proofs, right, that it's valid. And so because of that, I don't need to maintain my local history or any local state. It's just attached to the block. And so like similarly, it you know, pairs well with this notion of getting rid of old history, because the blocks will just provide what they need. And again, this is still very much in the R&D phase, but it does change what's possible with the full node. So yeah, another thing to keep on the horizon. So basically, the point I'm trying to make here is that what is Ethereum? Is it a consensus protocol, or is it some archival service? I would say it's a consensus protocol. It should not provide any archival duties. I think that the position of the EIP is aligned with this as well. I think that, you know, even pointing to some of these like forward-looking research directions that seem to have a lot of support so far, you know, it's very much the former, not the latter. So there's 4.4s. I'll give you a short summary on the latest. So we have like a very small working group of like the co-authors and some people who are interested to help. Probably the best way. So actually, we just opened a channel on the ETH R&D Discord this morning for history expiry. So I'd actually direct you there. But that even happened in between when I made this slide and now. But feel free to DM me if you want to figure out how to get involved. I can direct you to where you need to go, or go to the ETH R&D Discord. There's a history expiry channel, just like say hi there. And similarly, someone will direct you into some space to help. I did want to say, like, we put out the EIP, and it's been discussed a little bit among core devs. I think generally there's been a lot of, I guess, pushback. There's been, I think the main point so far, the main takeaway so far is just that like people want to see more from the EIP, and that's understandable. So anyway, I would still say we're still very much in like a information gathering stage, trying to talk to as many different stakeholders across the ecosystem as we can. And that's what I mean when I say it's like, you know, if we do change this guarantee, it's almost like a social issue, right? It's not even like the technical details are not even that, you know, I mean, they're important, but they're not like the core issue here. Like core issue here is like, you know, would you live with an Ethereum protocol that works like this and not like it does today? So point being, you've probably heard of DevConnect that's happening in April. There's a Fellowship of Ethereum Magicians Council gathering. It's called the OG Council. And anyway, I'm also leading a session there on this EIP. So if you're there, come say hi, or let me know what you think about the EIP. And then I just wanted to call out this user Abstract DF. I think his name's Henry or Henry. Either way, he's been working on prototyping an actual demo of how the EIP would work. So essentially saying, okay, if we do have all this chain history, like what are the actual details of how it's laid out, you know, in terms of like schema and the data types and all that. And then also taking existing like off-the-shelf execution clients and then giving them an import and export feature to then, you know, work with this history. And I think latest I heard is that he's working on an update for DevConnect as well. So should be some more exciting stuff soon. And I think that was it for me. Yeah.
Well, thank you so much. It was a nice overview, great presentation. And as you were trying to say, I believe is like readiness of the community for this big change, right?
Right. Yeah, like if we do move ahead with this EIP, it'll probably be something that takes like it'll, you know, it could take a year to like transition, right? Like it is actually kind of a big thing and like touches many different pieces across the whole stack. So first you need buy-in, and then the question is like, okay, how do you like actually roll it out to users in a way that is like nice? And then yeah, just making it happen. And like that whole process, you know, will probably take quite some time. Not a simple change.
Yeah, I agree. I agree. I mean, this is again one of a kind proposal, and I understand the pruning will help. Sometimes running full node is concerned just because of hardware, and this is a concept that needs to be accepted by the community if we want to bring this big change, right? But this definitely looks like a futuristic proposal, so I hope this talk will help people to understand it even better. Yeah, I have a few questions for you. If you don't mind, I can take one by one.
Yeah, go ahead.
All right. So we did talk about historical data, right? You did mention about how we can verify the data and who will provide it. So I want to go a little bit deep in it. So how important do you think this historical data is for normal people running nodes? Like how common it is to refer back to these data?
Sorry, repeat the question. How common it is for people to use this whole data?
That's right. Yeah.
Yeah.
I mean, like how often do we use it?
Yeah, right. I mean, that's a great question. It's a little bit hard to say without like doing some sort of like, you know, user survey, which perhaps we should do. I would hope to like speak again to like, you know, it brought like a wider variety of sort of stakeholder types during this ETH Magicians Council. Because again, so far we've mainly gotten feedback from core devs, and obviously, you know, we should get many more people involved. Point is, I would want to ask them and say, okay, like, yeah, like, you know, I gave sort of an example of like auditing a Gnosis multisig. Like, is this something you do? Like, is this something you'd want to do? Like, do you think that would be an issue for your dApp, your application? If, you know, you didn't have this guarantee, how would that look? I don't like, again, just like off the top of my head, it's like, you know, like how often have you gone back like 3 years to like find a transaction in some block? Like you haven't, I haven't, like no one on this call has, no one listening to this call has. Like, I think there are definitely like archival services and like you can go get that information. Like there are people who index the chain and they have it. It's certainly important, right? It needs to be available, but like it shouldn't necessarily be a burden on every user. And this is what 44 is trying to get at, is that you should be able to run a full node without needing to like keep all of this history.
That's right. I think this kind of question, if answered well, like if we do not have tons of users having looking for access of these data, this proposal make a lot of sense there, right? So I was looking into some details of the proposal, and it talks about the archive nodes. So I'm wondering, like, do you have any visibility on the archive node with state sync functionality? Because currently, if someone wants to bootstrap his node for the first time, the only way is like getting into full sync. And with this proposal, full sync will not be available. So the question is, do you have any visibility on archive node?
And just like how they'll change with the EIP?
Yeah, you know, how I understand that this is currently under development, and I'm trying to understand here is like, is this development will be before the EIP-4444? I mean, is there any dependency of EIP-44s on this particular chain? We just don't want to break the chain, right? We don't want that data is not available. What are the backups here?
Right. Yeah, I mean, the way that you would roll out the EIP is like, you know, you'd probably have a year, or like, I don't know, we could even say 2 years. Like you would have like a very long period of like essentially transitioning the network from current state to this state. And so because of that, like, yeah, I wouldn't worry about lack of availability. Like, I don't think, you know, we wouldn't bring this EIP to mainnet without like everyone being very comfortable and, you know, keeping the history around. We would have very concretely answered all the questions. Like we would know, okay, you know, these players have committed to hosting the history. Here's how we can get it. All of that. We have like, if we need some sort of like Shim client, then like that exists and has been like tested. Yeah, so I wouldn't worry about like losing the history. And yeah, I mean, so archive nodes could be like a data source, right? Where like if you're in an archive node today, you could basically like honestly just keep doing that. You could, whatever that looks like, you could keep running an archive node, and yeah, provide the same service.
Right. So you did talk about Shim client. So is it like currently available for people to run, or is it something like being expected that it will come in future?
Yeah, that's like, I think we wanted to see like probably more like positive enthusiasm before committing, the resources to having someone go and like build a Shim client. But the thing is, you could even just take like, for example, Geth today, and you could basically just like, I think with very minimal modification, turn it into the Shim client. Like that's not, that's not, again, I think a huge technical ask. It might, again, take resources to like maintain and develop, but it's not like, again, it's not this like big open-ended research question that we just don't know how to answer. It's essentially taking execution clients like they are today and like either modifying them just a little bit to like parse history. And so that's, when I mentioned Henri here working on the prototype, like that's what he's doing, is sort of demoing how you would take, I think he's working in Geth, but how you would take Geth to like, to do this. Yeah.
Yeah, that makes sense. There is another development work I'm aware of, that is like a portal network. So PEEPanEIP, who is the lead developer of portal network, was with us on this show a few months ago. And as I understand, portal network also propose different way to use like less bandwidth and usage of light client for running an Ethereum chain. And I also remember having some breakout room discussion, developers discussion on this. So I'm curious to know, what is your take on portal network versus EIP-44s?
Yeah, I mean, I think they're certainly complementary. Like, my understanding is that they're still working on some of the questions around, the specifics of the portal network, but essentially, I think in its full vision, the portal network very much acts like an archive node. Like that's the way to think about it, is that it's this like DHT, this like decentralized network that is also an archive node. Like that's sort of an interface it provides to users of the portal network. And yeah, so that could even be like, you could say, oh wait, there we go. I went back to here to like example providers. Like you could even just tack on the portal network, right? So yeah, I mean, definitely they're complementary, and yeah, I'm definitely very excited about the portal network and like hope to see further developments there. And yeah, if 4.4s rolls out, then definitely like that could just be another piece to the puzzle. Is like, sure, you could go to a torrent, you could like go to a traditional data provider, you could go to the portal network.
Right, that's quite relieving to hear that, because I remember a conversation in which the scenario was like either or, but it looks like it's complementary, and that is really good to know. Thank you.
Yeah, I don't see why they would be exclusionary.
Yeah, right. All right. Moving on, the POS weak subjectivity. You did mention that it's like tangentially related to the proposal. So I'm curious, like how this proposal is going to help user running a client node. I suppose this is like after the merge. Obviously, we are looking this proposal in a long run. So, and we are expecting merge before that. So yeah, how is it going to help users run a client node?
Right. How will it help them run a node with regards to weak subjectivity, or?
Yes, with respect to weak subjectivity.
Right. I mean, I suppose so. It would imply you would need less of the chain to download, right? So like, if you have like, so for example, like beacon chain nodes today, like if they, like if you sync a beacon node, you have the full history, like all the way from Genesis to now. And we actually want nodes to do this because again, we want to, it's basically an availability guarantee. And yeah, if we move to a 4.4s kind of world, then we change that guarantee. And then yeah, rather than needing to like start from some weak subjectivity checkpoint and then like sync all the way back, to the very beginning. You could basically just like stop 1 year. If that's the period, for example, you could stop 1 year behind. And so, yeah, again, you'd still have all the benefits, the savings in terms of resources. And yeah, just now you're in a proof of stake world.
That's interesting. It is really very interesting to know that Ethereum developers are not just preparing for merge, but also post-merge, like what all changes can we bring in.
Oh, yeah.
Yeah. All right. So again, from the proposal, this is related to JSON RPC changes. What are the breaking changes to JSON RPC endpoints? And what do you think, what kind of project will be affected by these changes?
Yeah, so like, I mean, honestly, that's probably the like biggest, I think, or like the most contentious point of the EIP is that there is this breaking change. So like, we can sit here and be like, oh, you get all these savings in terms of like the disk footprint you need, less bandwidth to like move blocks around, less compute to verify the blocks, because you get rid of all this history, and that's great. But what that means is that now as a, dApp developer, a user of this JSON RPC endpoint, you could ask for some history and your node just might not have it. And so the question then is like, okay, what do I do? The like easy answer is you say, okay, yeah, this node doesn't provide this anymore. You go to some other service like Infura. And again, that gets to questions of centralization, and that's like not like an ideal answer. Again, Portal Network would be a great solution here. Along with being an archive node, right? It also wants to expose this like Web3 interface. So you could imagine the JSON RPC sort of API being sort of implemented by the Portal Network. So that would be really cool. But the point is that there's a breaking change, because today you can ask for any history and you'll get back an answer. You would not have that with 4.4s. And again, this is like part of just having like a very frank conversation of being like, hey, the way the protocol works today is not going to make sense 20 years from now. So we need to do something. Yeah.
Yeah, it's more of convincing community. That's right. All right. So moving towards more EIP specific questions. My first question is about EIP wordings. Some users in the ecosystem seems to be like particular about word that we use for a standard, and EIP is a future standard. I'll be curious to hear your thoughts as a co-author. What do you think the usage of must, should, may, or may not be there in the proposal, and how far does it actually affect the enforcement of what is proposed with the proposal?
Right. I mean, so, okay, those are very important words. And I've had many conversations with other developers around when do you use one over the other. So like taking a step back, I forget the RFC number, but basically like before we had crypto, there was like people organized in a very similar way working on like the internet, right? And so they realized that somehow that it was important to, when you're writing specifications for these things, you need to be very precise. And like there's sometimes when you have like a feature or an aspect to your protocol that like it must work this way, so you use must. There's other times where you have a little more flexibility, and then you can say should. And again, this is important when you have this like sort of spec driven development or like a spec first workflow where the idea is that you have a specification for some protocol, and then now you can have different implementations. And like, again, this is a different talk, but it's very key to the Ethereum ecosystem that we have multiple implementations. It's like saved the network from like suffering from very terrible bugs in the past, and like we'll probably continue to do so in the future. So we have this like, rich client ecosystem. And so what that means is that these specs are very important, because that's how we all determine exactly what we are building. And so part of that is, yeah, you now are writing these like, probably English description versions of what the software should do. And so now you need to like be precise. And so we have these words must and should, and they help us do that. Let's see. I think I kind of went off on a rant. What else were you asking?
No, that's all right. Yeah.
I just keep rambling, so go ahead.
Yeah, I found that there is this conversation in Fellowship of Ethereum Magician, the discussion tool link, where people are saying that it should be must, it should be should, like kind of that. And I haven't seen that kind of conversation before. So I was just wondering, like, I understand it is important that whatever we want to achieve with the proposal should be achieved. And this is a big change. So giving right directions to community would be useful.
Right. And yeah, and that's the thing where like, maybe I'll think of an example, but essentially like you can have something where like, I don't know, like the things that are kind of coming to mind are like more examples from like the beacon chain and like the networking, for example, where it's like, it's actually very critical there, must versus should. Like if you have some validation condition that is should, where it should probably be a must, that then gives clients flexibility to implement it, you know, let's say either way, if there's two options, then what that means then is that you've now suddenly partitioned the network. Like you'd actually have a chain split from this flexibility. So like there are some cases where like must is very important, and like, you know, if there are specific examples in the IP, we could like talk about them, but essentially like that's what this comes down to is like, it does matter. It's not developers just being pedantic, and it can actually have like implications for security and all, you know, usability and all sorts of things.
Right. And especially when it comes to implementation for networking proposal, it is mostly on like client, right? It's not that it has to go with an upgrade, then everyone has to be on board at the same time. So when it comes to implementation, I remember you did mention about someone working on the prototype Henry. I think that is there for the Dev Connect. So that is with the Geth client, right? I'm curious, like, is there any parallel implementation working on with any of the consensus layer client? Oh, sorry, this is just the execution layer change, right?
Yeah, I mean, you can imagine like there might be things you want to do with the consensus layer, or like even the same thing where like you have a similar sort of guarantee around only keeping a year of history. But yeah, like this is primarily focused on the execution layer right now. And yeah, there's been some prototyping work. I'm not aware of any other serious efforts right now that could change. Also, though, I do want to jump back to must versus should for 1 second, because like I'll just give you an example, right? Like a very at-hand example with this EIP is like if the EIP was clients. So, you know, I believe what it says right now is something like clients must stop serving history 1 year in the past. Whereas if it said clients should or like could, whatever the equivalent would be, well, essentially, yeah, I guess should. If clients should do this, then that gives them the optionality. And the reason that's a problem is because then what happens is you'd have some nodes on the network that might not have the history and some that do. And then what happens then is that you have this issue where like, again, it centralizes the history to just a few actors. Whereas like if we say this thing must happen as of the CIP, it also forces us to say, okay, here's also this like other way to get the history. Like there's some other protocol. If you say should, then you actually like don't have to provide that. And then some people have it, but then over time, like network quality degrades and it just becomes a mess. So anyway, we'll stop that conversation, but it is an important distinction.
Yeah, right. It definitely will help. I think clarity on this part will help users to intake that.
Yeah.
All right, my last question for the day, it is about the readiness. You did mention about this is a long haul proposal, and we are expecting to see it in like somewhere around 1 year down the line. I'm curious, like, when do you think the proposal will be ready for review? When the spec is all ready, or when you think the community is on board, or like how long do you think that it will take to bring the proposal to the review status?
Yeah, that's a good question. So, I mean, I think that process has already started. Like, again, because of the scope of the change, I do think it's going to be this like very sort of ongoing thing that might take a year or more to resolve, if anything ever happens here, right? So, you know, with writing the EIP, we basically getting it out there. It's like now something people can like debate and say like, here's a specific thing, here's a specific like counterpoint. So that's really helpful. Again, I hope to over like the next like month or so, like get a lot like much broader input from the community. Again, mentioning this like Magicians Council and things like that. And yeah, I mean, I think even from here, getting I mean, yeah, the concrete next steps would be getting some sort of like prototypes of well, there's two parallel tracks. There's like prototyping the EIP, because I think that helps people like sort of conceptualize and like actually see what would happen. But then also, yeah, continuing this process of getting feedback and then kind of like, you know, keeping them in sync as we go. And I still think there are a lot of like open sort of, I think there's still, I don't think this EIP is at a place where it's like ready to ship and it's just a matter of convincing people. Like, I think there's still room for conversation here. And so, yeah, I mean, that could take, it could take a year just to get to a point where it's like, here's a formal spec that, you know, answers data layouts, and like, here's the torrent format and where the torrents live. And we've like gotten Infura on board and Etherscan and like the EF, and like they all are hosting the history and stuff like this. Like, yeah, that could take a while.
Right. But from the process point of view, what I think is like until the proposal is in the review status, it may get only limited review comments. Like even the involvement of community is less till the project is in draft status. Earlier, when we did not have this particular status called review, it was okay to keep a proposal in draft till it is ready for the last call. But now that we have review, we can keep it for as long as we want.
Right. And yeah, so then perhaps maybe we move it to review. I don't know enough of the details of that process right now to say how that would happen. Yeah.
Yeah, all right. I mean, I'm sure one of the co-authors of the proposal is an EIP editor, so you will be getting right directions over there.
That's a question. That's a question for Matt.
That's right. Yeah, but in general, I'm just trying to let everyone know that moving to review status is not difficult. You just have to create a pull request to change the status, even if you are not fully ready, because that is the period when it is open for review, the community review, the EIP editor review, as well as the core developers review. So it's just for review, it's not ready. And when it is ready, the proposal is changed to last call, where it stays for the next 14 days. And after that 14 days, an author can make a pull request to move it to final. So that's the process.
I see. That's helpful. Good to know. And yeah, I mean, the thing is, like, I think it's probably somewhere in between a like draft and review state, where it's like, I think it is more serious than a draft. I think that just based on the feedback we've gotten so far, I think people are going to want to see things like this prototype. I think just see like some more answers to, like, again, I keep losing my slide thing. More of these questions, right? Like having really solid answers, because that's the thing is, like, I think people agree that like the current state is not sustainable and we should do something, but you know, the concrete something is going to need to answer these questions. And so I think if we have more fleshed out around how to actually answer these questions, that will go a long way.
I'm sure that we can come back on this proposal maybe after 6 to 8 months down the line, when we have clarity on these things, because this seems to be like really important questions to be answered for this big change. Like merge is a big change, and removing history will also be, again, a very, very big change for Ethereum blockchain.
Right. Yeah, no, that sounds good. Definitely happy to give an update in some time. And yeah, hopefully by then we have more clarity. At least we have, you know, the EIP authors have we have more concrete answers to these questions.
That's right. That's right. Well, it's time to wrap up. So if any final thing that you would like to share with our viewers, Ethereum developer community, with relation to this proposal or in general?
Yeah, definitely. If you have feedback or you watch this and it made you excited or angry or something, like, let me know. Yeah. And yeah, we'll see where the EIP goes.
Well, I hope the information shared today will help the community have some background, and then they collect their thought when the proposal is actually available for review. So yeah, people, please make sure you follow the discussion tool link provided in the EIP to share your thoughts, your comments. If you find something is going wrong with your tab because of this proposal, come forward and share that with developers. And yes, one more thing, I missed to mention it earlier. Alex had been on our show to provide a talk on beacon chain accounting reform, which was after the Altair upgrade. So if you have missed it, check out the episode 34 to have an understanding of rewards and incentive on the present beacon chain, which is like after the first upgrade. And concluding the episode, on behalf of Ethereum cat herders, I thank the guest and other participants to join the call. Thanks our YouTube viewers for watching and sharing your feedback and comments. Should you have any question, reach out to us. Leave it as a comment, reach us on the Ethereum cat herders Discord. Check out the description box for all the related links. Subscribe to Ethereum cat herders YouTube channel if you haven't done it already. And next week, we are going to have another interesting proposal, that is EIP-4444, that account abstraction via entry point contract specification. So stay tuned, keep watching, keep sharing your love with Ethereum cat herders. Have a good rest of your day. Thank you, everyone.
Thanks, everyone.